All right, in 8.4, we're going to talk about scientific notation. And all scientific notation is it's a shorthand way to write really big numbers or really big decimals. So the first way we're going to go is we're going to go from scientific notation into standard notation. So these numbers are already in scientific notation. Now with scientific notation, you can only have one number in front of the decimal point. It's really the only rule. Okay? So notice that both of these examples here, there's only one number in front of the decimal point. If I were to write this as 32.5, that would be wrong because that would have two numbers in front of the decimal place. So scientific notation, the rule is you can only have one number in front. So if I'm going to take this sign, and scientific notation always has times 10 to the 7th. But not to the 7th. It's times 10 to some power. And all the times 10 means is that you're going to move your decimal point. Okay, every time you multiply by 10, it takes that decimal point and it moves it one place. If you're multiplying by a positive power, you move to the right. Think of a number line. Positive powers are on the right, positive numbers are on the right, and negative numbers are on the left. So if you have a positive power, you go to the right. If you have a negative power, you go to the left. And then any empty spaces you get, you just fill in with zeros. So if I'm going to take 3.25 times 10 to the 7th, I'm going to write 325. Now here's where my decimal point was. It's a positive 7, so I'm going to go 1, 2, 3, 4, 5, 6, 7. Here's my new decimal point. Fill all these in with zeros. So that's 325 with 5 zeros after it. 325 and 1, 2, 3, 4, 5, right? Yeah. Put some commas in, so that's 32,500,000. So you can see scientific notation is just a shorter way to write this really big number. Now what happens if I have a negative exponent? Well, I know I need to go to the left, so I'm going to put my 4.7 a little shifted over so I have space. Now I'm going to go 3 spaces to the left because it was a negative 3. So 1, 2, 3. Here's my decimal point. Fill in it with zeros and just rewrite it so it looks better. 0.0047. Okay, so that's going from scientific to standard. Now we're going to go the other way. We're going to take it and we're going to take a big number or a small number and turn it into scientific notation. So pause that and fill that in if you need to before moving on. Okay, so now we've got a really big number and a really small decimal. So again, you want to put the decimal point after the first non-zero number. There can only be one number in front of the decimal. So in this first example, 5 is the first number that's not a 0. So it's got to be 5 point, and then I put everything that comes after it. But I don't need to, when you have a big string of zeros, don't include that. I'm going to chop off, try that again. I'm going to chop off the number after the 3. So 5.103, bring down my times 10. And now, let's erase that so I can count. Okay, if I put the decimal here to figure out what your power needs to be and how whether it's going to be a positive or a negative, you want to count back to the original. So it's a number of spaces moved to get to original position. So the original position for me is all the way at the end of this number. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8 spaces, and I moved to the right to get back to my original position, so it's a positive 8. Okay, so let's try the next one. The first non-zero number is 1, so I'm going to say 1.25, always times 10. Now here's where I put the decimal. Let's get back to the original. 1, 2, 3, 4, but I had to go to the left 4, so it's a negative 4. Also, if you have a positive power, you're going to wind up with a very large number with zeros at the end, And if you have a negative power, you're going to wind up with the zeros in the front. You're going to have a very small number. Just helpful to know if your number is in the right form or not. Okay, so that's writing, standard notation, and scientific notation. Now let's do some operations with it. So we're going to do some multiplying and dividing. So here we go. Just like we did with, this is why it's in this chapter, because when we did this with variables, you multiplied the constants, the numbers in front, so 3 times 2 is going to be 6. And then times 10, keep the base, and you add the exponents. 5 plus 7 is 12. And that's already in correct scientific notation. Had I gotten a 2-digit number here, I would need to fix it. But I don't need to fix this, so I'm done. Now a division one, giving you a very tricky one here. So let's take it one step at a time. Let's do the, wait, let's see if I need to scroll down here. Oh, I do. Okay. So first, we're going to simplify into one fraction. So we're going to multiply the top numbers. Multiply the coefficients, 3.5 times 4, 0, 2, 14, bring in the decimal point. Okay, so it's 14 times 10 to the 8 plus 9 is 17, over 6.2 times 10 to the 5th. Okay, now this is not a great example here, but we're going to divide the coefficients. So 14 divided by 6.2 does not go in nicely, sadly, but it is about 2.1. And subtract the powers because we're dividing here. So 17 minus 5 is 12. And 2.1 is already in correct scientific notation, so we're going to be able to leave our answer. So 2.1 times 10 to the 12th. Okay, so that's scientific notation. So pause the video, and we'll try some examples in class.